This is a pretzel. Now, the common household pretzel is universally recognized for its unique shape and crunchy appeal. It's just a simple pretzel made up of wheat or rye, flour, yeast, sugar, salt, water, and butter. However, when you really look at it from a mathematical perspective, what the heck is this thing? So let's look into this. Mathematically, how do we define a pretzel? Now, in order to fully understand the answer to that question, we need to look at knot theory. So what is knot theory? Well, within the field of topology, knot theory is the study of mathematical knots. When you think of knots, the first thing that might come to mind is your shoelace or the various fisherman's knots. You might think of the knots and lashing that you did back when you did Boy Scouts or cadets or something. However, in mathematics, knots are defined differently. According to math, a knot is an embedding of a circle in three-dimensional Euclidean space. So what that means is that this is actually a knot. Sure, it's just a circle not tied in any way, but because it's embedded within three-dimensional space, it's a knot. What's even more interesting about this is that in the field of topology, a circle is considered more than just its geometric definition, but can be constituted by its various homeomorphisms. What that means is that this mug is also technically a knot. So is this donut. So is this. And this. But what about this pretzel? Well, we'll get there. Let's dive deeper into knot theory. Let's explore one of the basic concepts of knot theory. This is the most basic concept, and that is the concept of equivalence. So as we've seen, this is a knot. In fact, its technical name is the unknot, or trivial knot. Now let's take a look at this knot. Now, believe it or not, this is actually also the unknot. And the reason for that is because I can untie it like this, and it will still end up like the unknot. This means that these two knots are equivalent, because when they're reduced to their simplest form, they'll look the same. So with that in mind, let's take a look at this knot. This is the trefoil knot, a slightly more complicated knot. I mean, this one looks kind of like a pretzel, right? But not quite. Other than the unknot, it's considered to be one of the simplest of all knots because it's the only knot that can cross over itself 3 times. Now, there's no way to unravel this knot any further. Therefore, it's a prime knot with 3 crossings. And there we get into another important point. Knots are categorized by their crossing number. This knot has 4 crossings and is called the figure 8 knot. This knot has 5 crossings and is called the single foil knot. This knot also has 5 crossings, but it's not the single foil knot. It's actually the 3-twist knot. Why? Because although it has the same number of crossings, the crossings occur in different positions. Therefore, there are actually 2 different types of knots with 5 crossings. In other words, the same number of crossings, but different variants. The knot family with 6 crossings has 3 variants. The knot family with 7 crossings has 7 variants. You see a pattern here? The higher the number of crossings, the exponentially higher the number of variants, to the point that knots with 16 crossings can vary by 1,388,705 different possibilities. So, what's the point of all this anyway? Well, one of the big questions in knot theory is how many knot combinations exist? Within a prime knot, how many equivalents can we find? Years and years of study has been dedicated to find the answers to these questions. Mathematicians have also explored adding knots, developing notational languages to categorize knots, linking knots together, and even tying spherical knots within higher dimensions. What I found is that knot theory is actually incredibly complex, intricate, and most of all, fascinating. However, have any of these mathematicians ever asked the question of where the pretzel ties into all this? Well, actually, yes. Let's go back to our pretzel. So according to knot theory, this is actually not even a pretzel at all. Actually, this is. That's right. This is one of the 2,176 variants of the 12-crossing knot, and claims the title of the pretzel knot, despite not having any resemblance to the traditional pretzel whatsoever. So there it is. There's your pretzel knot. It's there. It exists within math. The pretzel knot. Behold. So although there is a mathematical pretzel, is the pretzel as we know it even a knot at all? Well, the short answer is, it's not. I mean, it's not.